Okay, so now with 3.3, we're going to kind of go in a different direction. We're going to go back to solving equations, and so specifically higher ordered polynomials. So 3.3 and 3.4 are going to go together. 3.3 is kind of an introduction to teach you how to use synthetic division to help you in the process. So the big picture is we're going to be solving higher order polynomials that are not factorable. So far, what we have in our toolbox is factoring, quadratic formula, factoring by grouping. But now we're going to look at using a thing called synthetic division. So right now, we're just going to focus on the synthetic division. It is kind of an interesting process. It's not a very difficult process, but it's kind of different if you've never done it before. And so on this first example, I just really kind of break it down at like every step, every detail I could think of to kind of explain it. Now, like I said, it's not actually hard. It's just kind of weird. And so just kind of bear with me, but let's go ahead and start this. So right here we have an example. We have 3x to the third power plus 8x squared plus 5x minus 7, and we're going to divide it by x plus 2. And so the way synthetic division works, you might have done long division before, and long division would be where we would take the x plus 2 and we'd actually, divide it into 3x cubed plus 8x squared plus 5x minus 7 and so on. So there's a way of doing this, and it can get a little messy. And so what synthetic division does, it's actually the same thing. It just simplifies the process for us. And so the first thing that you do is take the divisor, set it equal to 0, and solve for the variable. So you take x plus 2 and subtract 2 from both sides, and so you get x equals negative 2. Then the next step is to list all the coefficients of the polynomial that's being divided. And so we list all the coefficients are the values in front of the variables, or if we have a constant at the end, right? So we go ahead and list all those. And then typically what most people like to do is draw a half rectangle around those numbers. And then we put the value from step 1 on the outer left side. So the 3, the plus 8, the plus 5, and the minus 7. So I have them all written here. And I made like a little half of a rectangle right here. And then I call it my magic number, and you'll see why in a minute. So I put that negative 2 from step 1 right there, right? Kind of weird so far, but nothing too crazy, right? Okay, so the next part is going to be an algorithm. It's going to be a process that we kind of do over and over again until we get to the end, okay? And so what we do here, step 3, rewrite the first number that's inside the half rectangle below the horizontal line. So I like to draw like a line and an arrow and put that number right there. So you'll always take that first one and basically drop it. I like to say I drop it. So we drop it down, okay? Then what you're going to do is multiply it by the number on the left side, or like I said, I like to call it the magic number. So you're going to multiply it by negative 2. Then you put that result up into the right below, like your second column right here, right below the 8. And so 3 times negative 2 is negative 6. So I put it right here in my second column. And then what we're going to do is add the numbers together in the second column of the half rectangle. We're going to add those numbers together. So 8 plus negative 6 is 2. Okay? And then basically I'm going to just do the same thing over again. I'm going to take this, I'm going to multiply it by negative 2, which is negative 4. And so I put it in my next column, column 3. And then you add those two columns going down. 5 plus negative 4 is 1. Okay. And like I said, this is going to be weird. It's going to take 2 or 3 times that you do this, but once you've done it a couple times, you'll find it fairly simple. So we do it again. 1 times negative 2 is negative 2. I put it there, and then I add that fourth column together, negative 7 plus negative 2, which is negative 9. Now, when you get to the end, this is where we want to put the problem back together. So what we kind of do, like I said, this is the same thing as doing long division, but what we do is we basically remove all the variables. And that's what's supposed to make it a little bit a cleaner process. And so see, we're only dealing with numbers, right? But once we're done, we need to put the variables back where they belong because they are there, right? We have our x's, right? So what you do is you just start lining, you put them back with their variables, except you drop it down by a power. So if you remember, to start with, it was 3x cubed, then plus 8x squared, and then plus 5x and minus 7. And what we're going to do is we're going to put those numbers back where they came from, the new numbers we got, but we're going to drop everything down by a power. So then this becomes 3x squared, and this becomes a plus 2x. And then this becomes a plus 1, and then this is known as my remainder. My remainder was -9, and what you do is you just tack it on divided by the original divisor, which was x plus 2. That's what we were dividing the polynomial by. Okay, so I know, you know, if this is the first time you've ever seen this, you're going to be like, that was kind of weird, right? But the good thing is, you know, we're going to do a lot of them, and it really isn't that hard. It's not a very hard process. It's just multiplying and adding, really. And so just kind of be patient. So like I said, that last term is known as the remainder, and that will play an important role, and we'll talk more about it in a little bit. But right now, this is more about, like, let's just at least get the process down. And then once we have the process down, we'll talk about the meaning of, like, what does this mean? How does this help me, right? So let's go ahead and go down here. And so, oops, we're going to do the same thing on this example right here. So I take the factor. Step 1 is take the factor, set it equal to 0, and solve. So I'm going to set it equal to 0 and solve. So x equals -4. That's my magic number right there. Okay, I like to call it my magic number. I'm going to draw my half rectangle now, and I'm going to put the -4 over here. And then what I'm going to do is I'm going to take all these, and I am going to write them without the variables, okay? And quick note, so I have an x cubed, but you want to count down x cubed, x squared, x. If you're missing any of those, you have to fill in a 0, and we'll see that on example 2 in a minute. You'll see that we go x cubed, and then all of a sudden we go to x. And so that's something I'll talk about in a minute, okay? So here we go. So I'm going to have a 3, and then I have that minus 2x squared. So I'm just going to put -2. That's my second column. Then a -7. And then a +5. So this is my setup. And then the first thing you do is drop the first number. Drop it right here. And then now we follow that algorithm, that pattern where we just multiply, and then we put the value here, and we add, and then start all over. So 3 times -4 is -12. -12 plus 2 is -14. -14 times a -4, so a negative times a negative, that'll come back as a +56. Okay, number's getting kind of big. Okay, and then let's see, 56 plus -7 is a 49. Okay, and then 49 times -4, it's going to give us -196. Okay, and then we'll add that together, and that'll give us -191. So next, now we're going to put those coefficients back where they belong. So what we're doing, we're dividing the polynomial by x plus 4, and so the result becomes 3x, and then we drop it a power, so it'll be squared, minus 14x, and you just kind of count down as you go from here. And then the next one won't have a variable, it would just be plus 49, and then last but not least, we have our remainder here, which is -191. So I'm going to put it as a plus, and I'm going to put -191 all over my divisor, which my original divisor was x plus 4. And there we go. And so if you've done long division before, this is the same answer. And if you've done long division before and you remember, this process is actually a lot easier than doing the long division with the variables involved. It's very easy to make a mistake doing long division. All right, let's try another one here. Now, as I mentioned before, if you're missing something, you kind of have to fill it in. So we'll put a 0x squared. So we're missing the x squared, so I actually do need to put like a space holder, basically, okay? So first things first, we'll go ahead and take the factors, set it equal to 0, and solve. And so our magic number is going to be 3 this time. So I'm going to make my half rectangle. I'm going to put the 3 right here. And so now I take the coefficients 2, and then I do have to put my filler, my spacer right there, 0, 7, and then -5. Okay. So we'll go ahead and drop the first number. And then let's see, 2 times 3 is 6. 6 plus 0 is 6. Then we do the process again. We're going to multiply 6 times 3 is 18. 18 plus 7 is 25. 25 times 3 is 75. 75 plus a -5 is 70. So sometimes these remainders can get big. And I mean, as we get more into it, they won't. But like when we're just starting to practice on your homework, you might get some 3-digit, maybe even a 4-digit. Just, you know, it's fine to use your calculator. It's not a big deal. And so then what we'll do is now we're going to reposition these numbers where they belong with their variables, but we drop it down by a power. So you just start with the highest power and then count down. So this is going to be 2x squared, and then the next one will be a plus 6x, because remember we did put a spacer in there. So the next one is x. And then the next one will just be a constant, plus 25. And then last, we'll have the remainder over the divisor, which was x minus 3. And there we go. So this will be a good stopping point for part 1. And so the main thing about this first part is we just want to make sure that you can do the process, the synthetic division. And so in my next part, we'll start to kind of talk about what does this mean? How is this helpful? Why am I doing this? And so that's where we'll pick up next.